So we're talking about, talking about transformations. So this is recapping. All right. So if we have translations, so translations means a movement. So we're moving the graph either up or down and left or right. So the way they say it in maths here or whatever, so we know if we move H units in the positive direction of the x-axis, we see the x value is affected. So what we've been doing is we've been saying, all right, we're going to talk about our new point. And if we were going H units in the positive, we're saying that we take the normal x and you add H, whatever amount of units would get added to it. And then down here we talk about, so if you were going negative, it would be minus, yeah? And now down here we talk about the y. If they say you have movement, a translation of k units in the positive direction, so we see our y value of our coordinate, we see the original one, and we might see if it was positive direction plus h. We've found that this is the easier way to probably work them out, and that's what we've been doing. So let's do this example here, and I'll do it with you. So find the equation of the image of the curve with the equation y equals fx, where fx is y equals x squared. So pretty much all that has just pretty much told me that the original formula is this, okay? Y equals x squared. Now we're going to do a translation of 2 units in the negative direction of the x-axis. So I'm going to start thinking about my new x point value. Now, it said 2 units in the negative, so I would get the normal, I would minus 2, okay? And then it says that we're going to go 4 units in the positive direction of y. So my y value has changed to y plus 4. So the next thing we do is we want to rearrange, because our formula here is y and x squared. So we want to rearrange these to be the formula where it's this x by itself for the first one. So if I move the 2 over, I get 2x plus 2 equals x. Are you happy with that? Yeah? And then if I move, I'm trying to get this y by itself, so I'm going to move the 4 away from it, and that would create that y dash minus 4 equals y. Okay? So what I'm going to do now is I'm going to take what x is and y is and put it into here. So over here, I'll just do it over here. So y is actually, y dash minus 4 and equals x squared. Well, x for us now is this, but squared. Okay, once you've written out the formula, we don't need to have those little dashes in there anymore. So we might change that out. And we also might not really want the 4 on that side. We'll put it over that side. So we end up with x plus 2 squared plus 4. So there's our new formula. Okay? All right, now we're going to look at dilations and reflections, and once again we're going to think about how it affects the point. So if you have a dilation from the x-axis, so you see dilation from the x-axis, you actually can see it's the y value. So if they said a factor of a, so say that was 3, then this would become 3y. So it's actually the y value that would get affected. And then if you look at a dilation from the y-axis, it's actually the x that gets affected. So you just got to remember that which one gets affected. It's a bit of memory work, and it's the opposite, isn't it? Now, if you go into, let's do an example here. So determine the rule. So they want the rule from of the image when the graph of y equals 1 over is dilated by a factor of 3. Now, the first question is saying from the y-axis. Oh, sorry. So, A, we're going to do from the y-axis. So, if it is from the y-axis, the x is affected, isn't it? So, dilated by, so x will become 3x and y didn't change. Yes? So, really, we only have to really rearrange this guy, and that would be x dash divided by 3 equals x, and we can still use this one. Now, the original formula was y equals 1 over x, but now, sorry, I'm going to run out of room. I'm going to write y dash equals 1. Now, x is actually x dash over 3. What happens when you have a fraction divided by a fraction? You actually times by the flip, don't you? Yeah? So my equation ends up being 3 over x. Yeah? Okay? So, therefore, and we don't need the dash, you could summarize that up to be 3 over x. Okay? Is everyone happy with that? Yeah. So that's A. Okay, sorry, I'm going to rub out because I've run out of room. But you guys don't have to. I'm going to do B now. Sorry. Alright, so now we're going to do the B. Oh my god, is my battery dying? B. Here where we've got it, it's from the x-axis. So when it's from the x-axis, it's the y that's affected. So we are going to say it's 3y. You'll rearrange this one to be f dash divided by 3 equals y. And then we pop it into our original equation. So instead of y, it's actually y dash over 3 equals x dash, 1 over x. That's the same. So can I move that 3? We don't normally keep a y like that. We're going to move the 3 over. So we'll get y equals 3 over x. Now, yes, that has not, the graphs still look the same in the dilation factor. But if you have a think about it, this graph, 1 over x, what does that look like? Doesn't it look like this? Yeah? Do you remember that? So the dilation from the both axes wouldn't really look different, would it? Nah. So that's why that one might have been a bit throwing for you. So reflections see the value going negative in the opposite coordinate. So see a reflection in the y-axis, you see a negative in the x, in the new point. So, and then a reflection, sorry, this is where he wrote the same thing twice. So you actually meant to write a reflection in the x, you would see a negative in the y. And then you just create the point the same way. So if we were writing out the point up here, the reflection in the y-axis, we'll see our new point be negative x and y would remain the same. But down here, reflection in the x-axis, we'll see that x stay the same, but we'll see the y become a negative like that when we work them all out. All right, let's go see if they've done an example. All right, so let's practice. Oh, we're up to combinations. So you guys were doing a little bit of this yesterday, yeah? So example 3, find the equation of the image of this. So this is like telling you the original. And the first thing they're asking us to do is a dilation factor of 4 from the x-axis. So doesn't that affect the y if it's a dilation from the x-axis? And followed by a reflection in the y-axis. So if it's reflected in the y, doesn't x become negative? Yes. So you could rearrange them. So it's x dash is actually negative equals x, and this one would become y dash divided by 4 okay? And then you pop it back into your original. So the original was y equals 1 over x squared, but we're going to put the new ones in. So it'll be y dash over 4 equals 1 over, now, negative x squared. Just tidy that up. We don't leave the 4 down there, do we? So it's dividing on that side, so over the other side. So I've got y dash actually equals 4. Now, negative x squared, it's still going to be x squared, isn't it? Yeah? So there's my formula in the end. And if you think about this graph too, so this is a truncus, isn't it? Yeah? And if you reflect it in the y-axis, does it look any different? No. So can you see how that negative x of course it didn't make a difference because you can't see a difference when you reflect it. Just to show you, think of those things, it will help you problem solve, and you've got to debate it out, because otherwise you go, I think I'm wrong. Nothing changed. All right, so let's do the next one. A dilation factor of 4 from the x-axis, so that means y is affected, followed by a translation of 2 units in the negative direction of x, so that'd be x minus 2, and 3 units in the positive direction of y, so I'm going to say plus 3 as well. Yeah? All right, you need to... Sorry, they probably didn't. I'll give them a bit more room. It was minus 2, wasn't it? Yeah. All right, I'm just going to rearrange them underneath. So, rearranging this one, you'd move the 3 first. So, you'd have y dash minus 3. Then you'd move the 4, which would divide everything, equals y. Okay, so there's that little guy there. And the x1 will be plus 2 equals x. So there's that. And I'm going to go pop it into the original equation. We're still using the same one, x squared. So I've actually got y dash minus 3 over 4 equals 1 over x dash plus 2 squared. Okay, we would not normally leave it like that, so I'm going to move everything. So the 4 would, tidy this up, the 4 would dividing would multiply on the other side. So I'm going to end up with 4 over x plus 2 squared, and I would have also then brought the minus 3 over and become plus 3. Okay? The order was important there. They told me which way to do first because it would make a difference if you dilate after. The process would be different. Okay, so let's do this last one. A translation of 2 units in the negative direction of x, so x minus 2, and 3 units in the positive direction of y, so y would be y plus 3. Then we've got followed by a dilation factor of 4 from the x-axis. So when that happens, doesn't that affect the y? But be careful, it's timesing it like that, isn't it? I've already added the 3, so I've got to times that whole thing by 4, okay? So now, when you rearrange this guy here, it's actually going to be y dash divided by 4, then I'll minus 3 equals y. Can you see how that made a difference? It will make a difference. And then, so I've done that, and this one would have been just x dash plus 2. Okay, and into our original formula, which is that. So I pop them all in. So I've got y over 4 plus, minus 3 equals 1 over x plus 2 squared. Then move all the other things. So first, I'll move the 3. So I've got y over 4 equals 1 over x plus 2 squared plus 3. And then I'm going to move the 4. And watch that, the 4 has to times everything. on that other side. So, So essentially, if I was multiplying that out, it'd be 4 over x plus 2 squared plus, is it actually 12? Yeah, because 4 times 3. We're going to determine the transformations that happened to get the graph of this to this. So what they want you to do is actually write it out and you tell it. So if you think about what we would have done, originally, remember, we probably would have ended up, if I move that 1 back over, it would have been minus 1, yeah? And this 3, let's say it was dividing like that, equals x minus 2 cubed, yes? So can you see, this would have been my dash and that would have been my dash there. Yeah, is that true? Yeah. Yeah, and then if I wrote that out, I would have said that x equals x dash, I would have had that, and you would have, oh sorry, this is cubed, yeah? So you would have put that in there, and then y would have equaled what you have there, so minus 1 over 3, yes? Now, because you've got to tell them what transformation it is, you sort of want to go back and get it to what they told you to do. Remember, we would have rearranged that. So if I move it back, I would have x plus 2 equals that, yes? And then this one would have been y, 3y, yeah? Plus 1 equals thing. So now what you need to do is tell me, what did we do here? We have, haven't we translated the graph? Translated 2 units in the positive, yeah, direction of x. Is that what that says? Yes. Yeah? And what about this guy? What's the first thing we did? To get that dilation of 3 on the y, what did we do? We dilated 3 units from x-axis. Wouldn't that get... Yes? And then we translated what? 1 unit in the positive direction of y. Yes? So those ones have to be, this has to be first and then second in this case. All right? And I think mine's going to die, this laptop. Anyway, we'll go again. So we're going to look again. What did we do to get to this and this? Well, can you see y must have been just y dash. That hasn't changed. But x would have equaled, wouldn't it been 4 dash x plus 2? Yeah? That's how the x changed. All right, so let's rearrange this x. So I would have had x minus 2, and then I would have had divided by 4, and that's what I would have got. So we've got to explain these transformations. So the first thing I did was I translated negative 2 units in the negative direction of x axis. And then if I've divided by 4, or could I say times by a quarter? Yeah? Can you see that's the same? Yeah. If you times by a quarter is the same as dividing by 4. So I'm going to say I then dilated by a quarter unit from, now because I want the x, so it's from the y-axis, isn't it? Yeah. Oh, that's probably bad English. Dilation of a quarter from the y. Yeah, you should write it like that. Sorry. Bad. You can see I'm a maths teacher. Sorry. So a dilation of a quarter unit from y-axis. That's probably a better way to say it, sorry. So, boys, with these ones, this is the original going to that, okay? So, if you look at it, we would have had, obviously, this one. So, y would have equaled, so that's what we got. So, we've actually got, it went backwards. So, then when you look at, that one would have been the same. But, oh no, actually. No, sorry, I tell a lie. I take that back. Alright. You probably need to rearrange this first. So, actually it was y minus 5. And I might even say divide by 2 would have left me... Okay, so this is the original, and then it went to this, okay, down here. So we had y minus 5 over 2 became this y. And then we had x, what was x? How did we change x? We had x minus 1 was just x. Alright, so you need to go backwards to see what to eliminate it. So we were from this and we want to go to that. So what had happened is you need to rearrange it. So you watch it and we would have had, it would have equaled y times 2, like that. Oh, sorry. I've moved the 2 first. And then I would have had 2y plus 5. So this is how I would have started with it. So my new y would have looked like that. So this was the y in there, and this is the x in there. So if you rearrange this one, x dash would have been x plus 1. So then you write out what they are. So over here, this first we dilated it by 2. So that's a dilation of 2 units in the x-axis because it's affecting the y. Dilation of 2 units from the x-axis, sorry, even better. And then this guy, that would be 5 units in the positive direction of y, sorry. Direction of y-axis. Okay, this bit would have been 1 unit in the positive direction of x-axis. Now, if you have a look, just go back to this original. See how it's plus 5. You want the graph to drop down negative, don't you? Because you want to go back to that basic one. That's what we've done, isn't it? We've gone down 5. Do we not want it to go back where it went from? So this caused it to go to the right. Now we want it to go to the left. So you can see we've done that with the positive. And the dilation we've accounted for. We reduced it, we reversed it by changing it. Alright, so that's it. I'm going to stop there.